Monday, everyone. Today's video is going to be starting a new chapter. The first section is really review from algebra, and it is on 8.1, and the first chapter is systems. My T doing right of linear equations. So generally we have a standard form when we're looking at systems of linear equations, which is having an ax plus b y is equal to c. This is the standard form of an equation as opposed to the, say, slope-intercept, which would be y is equal to mx plus, in this case, it would be c. But you can technically use the slope-intercept form to help solve systems of linear equations. We are not going to be looking at that for this section, just because it's not going to be of any benefit down the line for the rest of the section. So for now, all we worried about is standard form. To recall, say, an example, we would have equation 1 as x plus 2y is equal to 6, and we're going to keep using this example throughout, and 3x minus y is equal to 1. We would have to find x and y values that satisfy both of these equations. So we need an x comma y to satisfy both. Now before we get into solving these, we're going to actually recall that there are 3 types of systems that can give us a different number of solutions. I'm going to do this in blue since it's kind of just a sidebar. So there are 3 types of solutions. They are independent, which means just one solution. Dependent, which means infinite solutions. I'm just going to write SOLS for solutions. And then there is inconsistent, which means no solutions. I know we've been working with sine and cosine a lot recently. So these could have multiple solutions because they are periodic. Linear are not periodic, they are linear. So that's why we only have one infinite or none. So in an independent solution, if I were to draw a coordinate system or a coordinate plane, I could have, I could have this as one of my equations, and then I could have this as my other. The one solution is the point where they intersect. In dependent solutions, we have an infinite number. Dependent systems, we have an infinite number of solutions. In this case, I could have this first line. In order to have an infinite number of solutions, my second answer is actually just going to be the same line. So I'm not going to draw it all the way, but this is now it's the same equation, so it might be like a, I'm trying to think of what this would be. This would be a minus 3. So we'll say, I don't know, x minus y is equal to 3 for both equations. Negative 3, actually. X minus y is equal to negative 3. This might be like an example of when you'd say, oh, well, they have the same equation, actually, so therefore they're dependent. If you didn't have one equation, you wouldn't have the other equation. And then inconsistent, in terms of slope-intercept form, this would be, and we can even write this in standard form too, so this might be like x minus y is equal to 4, and x minus y is equal to 7. If I were to switch these to slope-intercept, this would be x minus 4 is equal to y, and x minus 7 is equal to y. These, if we recall, are parallel lines. They have the same slope, but they have different y-intercepts. So if I go and draw this one really quick, it would be something like this. Obviously, these don't represent those two equations. Those both have negative intercepts. So this would be example 1, this is example 2, this is example 1, this is example 2. Okay, so that covers the 3 types of solutions, and then really from here we're just getting into how to actually solve them. We're going to have 2 different types of two different methods we'll look at. They are substitution and elimination. So if these seem familiar to you, that's awesome. They should be. We're going to start with substitution. Our first step is always going to be to solve for one variable. So, did I write one of these wrong? Oh yeah, I wrote one of them wrong. Or so it seems. Remember I said we're going to be using one of these equations. This should be an, I'm going to double check. Yep, this should have been a minus 11, not 1. We're going to see this example with the minus 11 multiple times, not the minus 1. Okay, so we're going to solve for one variable. So if I go back, I had 3x minus y is equal to 11, and I had x plus 2y is equal to 6. So for here, I'm going to just, you look at this guy, so I'm going to do 3x, I'm going to subtract 11 from both sides and add y. So I'm going to get 3x minus 11 is equal to y. Step 2, I'm going to substitute into our other equation. So in this case, our other equation is x plus 2y is 6. So I'm going to get x plus 2y is equal to 3x minus 11 is equal to 6. From here, we would need to distribute our term, our coefficient of 2, to both the 3x and negative 11. So I'll get x plus 6x minus 22 is equal to 6. Well, I guess technically this is supposed to actually be step 3. I'm skipping ahead. So step 3 is solve for first variable. So this should be in red. This should be in red. So x plus 6. I'm going to be smart. So this is x plus 6x minus 22. I just get so into the groove of just doing these that I skipped ahead of the actual step. So then here I have 7x. By combining the like terms, if I add 22 to both sides, I get is equal to 28. And then we divide by 7. And we get x is equal to 4. And now that I have x solved for, all I have to do is plug in x to solve for other equation or other variable. So in this case, I'm going to say x is equal to 4 in x plus 2y. So I'm going to get 4 plus 2y is equal to 6. Subtract 4 from both sides, you get 2y is equal to 2. So y is equal to 1. So we now have a solution, supposedly, which is x is 4, y is 1, so 4 comma 1. I have to, or I should, we should be checking our answers. What color have I not done? I want to have red values. I want to have some green value for orange. So 5 is to check solution. So I'd have 4 plus 2 times 1 is equal to 6, which is true. This is 4 plus 2. Then I'd have 3 times 4 minus 1 is equal to 11, which is 12 minus 1, which is equal to 11. So we are good for that. Alright, from here, I'm going to go into the elimination method. I'm going to give you an example that you should try on your own really quick. So I'm going to scroll up. So before you move on, pause this for a moment and then work on this problem using substitution. And then I'm going to start giving the answer. So we have x minus y is equal to 2. And we have 2x minus 2y is equal to 10. Just stop when you get to something that might be an inconsistency or once you get to a solution. Okay, so if you worked through this, you would have likely done x is equal to y plus 2, and then plugged in for x, so you would get 2 times y plus 2 is equal to minus 2y is equal to 10. You distributed, so you got 2y plus 4 minus 2y is equal to 10. And then you would cancel out your 2y's, so you'd be left with 4 is equal to 10, but that's not true. Since this is never true, so since it's never true, there are no solutions. If we had a true statement here, so if we had, say, 0 is equal to 0, then we would have infinite solutions. So in dealing with when we might have an infinite number of solutions, an example might be x minus y is equal to 2, and then negative x plus y is equal to negative 2. we would be able to say solve for, we'll do x in this case, so this would be x is equal to 2 plus y. We plug in for x, so negative times 2 plus y is equal to negative 2. We have distributing a negative 1, so this is negative 2, minus y plus y is equal to negative 2. This is correct. Our y and negative y cancel, and we're just left with negative 2 equals negative 2. So this would be infinite solutions. You may not always have just opposite terms with the same coefficients. You may have like a negative 2x plus 2y minus 4. So long as you can take out a common factor, pretty much good to go to have infinite solutions. Okay, so now we're going to look at elimination. I forgot to mention that these are really when you might actually use this, because there are good times to use this and there are good times to use elimination. So substitution is great for when you have just a coefficient of 1 with a variable. Because there's no need to divide by anything, so you're just getting, in this case we had like you're just getting a y that's just a coefficient of 1 by itself. Okay. The second method is elimination. For elimination, I'm going to start writing a problem over on the other side. I want to do one that actually requires us to multiply. X plus 2y equals 6. 3x minus 2y equal to 11. Sorry, this should be minus y. I skipped ahead. So 3x minus y equals 11. Elimination is when we add. Typically we just add because we usually multiply by a negative to subtract. But you can say it's when we add or subtract two equations to get a third one. In this case, if I were to add or subtract either equation, I won't get anything out of it. I'd have, if I added, I would have 4x. This would be 4x. This would be plus y is equal to 17. If I were to subtract, this would be negative 2x plus 4y is equal to negative 5. So it's not great right now, but we can fix that easily with step 1, which is really, if needed, multiply equations to get an opposite coefficient. When I say an opposite coefficient, in this case 2 and negative 2 would be opposites, 3 and negative 3 would be opposites. If you add them together, they equal 0. So my options are either to multiply equation 1 by a negative 3 or equation 2 by a positive 2. The first would give me a negative 3 plus 3, which would get rid of my x's. The second approach would give me a 2 and negative 2, which would get rid of my y's. I'm going to do this out by multiplying by 2. Actually, I wrote this in blank, so we're good. So really this is going to be, so plus 2, nope, not plus 2 yet. So my first step I'm going to do times 2, so I'm going to rewrite my equation. This is x plus 2y equals 6, 6x minus 2y equal to 22. 2 has to go to everything, including across the equal sign. We need the equation to say balanced, in other words, the same. Now I'm going to switch to blue for step 2. Step 2 is just add to get, or not to get, but to eliminate a variable. We're going to add equation 2 to equation 1. This will give us opposites in terms of my y coefficients. So I'll have 7x. This cancels out the 2 y's, so plus 0y is equal to 28. And this is the same example we saw from earlier. So now in this case, well, we would divide by 7. So step 3 is solve for the remaining term. So solve for remaining variable. I would divide by 7, I'd get x is equal to 4. And using green, we will solve for our eliminated variable. We do this with one of our original equations. I'm just going to use this first one. So I'd have 4, which is x, plus 2y is equal to 6. Subtract 4 from both sides, get 2y is equal to 2, and y is equal to 1. Step 5 would be to check. We already checked these earlier, so we won't check again. But we do know that our solution is 4, 1. So we'll look quickly at 2 more examples for when we have no or infinite solutions. And then we are all set. Apparently I wrote too big, and now I'm out of space. That's okay then. So we're going to have negative 3x plus 6y is equal to 1, and 5x plus minus, not plus, minus 10y is equal to 9. Okay. You might look and say there's nothing I can multiply just one equation by, which is fine. Sometimes we have to multiply both. In this case, I'm just going to multiply by the other coefficient for x. So I have a negative, well, sorry, not negative. This is 5, so I'm going to make this times 5. Since I want them to stay opposite, I'm going to just multiply it only by the number and not the sign. So I'll multiply by 3. This will give me a 5 times negative 3 is negative 15, and then a 3 times 5 is a positive 15. And we said we wanted opposites, so that's good. So my new equations are negative 15x plus 30y equals 5. And then it's going to be positive 15x minus 30y is equal to 27. You might already be looking at this and going, oh, we're going to actually be canceling two terms because I've got a pair of opposites. So this is 0x. I have a second pair of opposites, 30 and negative 30. So this is plus 0y is equal to 32. Well, this is 0 is equal to 32, which is never true. So there are no solutions. And then last but not least, if we had, say, 14x plus 2y, I think you're getting the point of the multiplying at this point. So I'm going to make this one a little bit easier. So minus 7x minus, not 2y, minus a y is equal to negative 2. I'd have to multiply equation B by 2. I'd get 14x plus 2y, so just bringing down equation A, or equation letter A. This would be minus 14, because that's 2 times negative 7 is negative 14, minus 2y equals negative 4. Next step, we add them. We have a pair of opposites, so this is 0x. We have a second pair of opposites, so this is 0y. And we actually have a third pair of opposites, so this is 0. So I have 0 equals 0, always true. So infinite solutions. That's it for today. We're going to be doing pretty much this tomorrow, but with more variables. So instead of 2 variables, x and y, we're going to be looking at x, y, and z in our equation. Since we have 3 variables, we will need 3 equations for our system.